Fresnel's Bi-prism. So what is Fresnel's Bi-prism? So it is made up of two identical prisms which have very small refracting angles. Okay, and then those two prisms are connected base to base. So suppose here we have a prism which has this very small refracting angle and it is the base. Now if it is connected to another identical prism to its base like this, then what we get is the Fresnel's Bi-prism. So it also has, the other identical prism also has very small refracting angle. So suppose this ABC is the Fresnel's Bi-prism, where these refracting angles are very small, which has a value of the order half degree. Each of them is of the order half degree. So this angle is around 179 degree. Okay. Now here we have the arrangement for the Fresnel's Bi-prism, which is used to observe interference fringes. Okay. In this case, when you use Fresnel's Bi-prism, the interference fringes are formed due to division of wavefront. Okay. So here, as you can see, we have a source, monochromatic light source, and then we have this Bi-prism which is placed perpendicular to the plane of the paper. Okay. Now, with parallel to this whole arrangement, a screen, XY screen is placed. Okay. So this monochromatic source, which can be a slit, this slit, this Bi-prism and this screen are all parallel to each other. Okay. So this edge, this AC and this, so this is the section of this whole Bi-prism setup which is shown over here. Okay. So this slit is this plane, AC plane of this Bi-prism, and the screen XY are all parallel to each other. Okay. So and on this screen we can observe the interference fringes. So when the light ray from this monochromatic source is incident on this Bi-prism, we can see that some of the light ray will be refracted from the upper half of this prism, okay, which is this one, and some of the rays will be refracted from this lower half of this prism, which is this one. So each half of the rays refracted the light in the different direction. So from the upper half of the rays it will be refracted in this direction, and from the lower half they will be refracted in this direction. So now let us show such two rays, one of which is refracted from the upper half and another from the lower half. So here, suppose here we have a ray which is refracted from the upper half of this prism. Okay. So here we have this ray, okay, which passes along this direction and reaches a point E on the screen XY. Okay. Then there is another ray we are showing over here which is refracted from the lower half of this prism, passes along this line and reaches a point H on the screen. Okay. Then so this is another ray. Okay. Now there is one ray over here which is passes through the prism without any deviation. Okay. And then reaches a point O on the screen. Okay. So here you see, as we know that when a light ray will pass through the prism, it will be suffer some deviation, and it will deviate towards the base. Okay. So here you see, when it is passing through this prism, it should have gone in this way, but now it has deviated, and it has deviated towards the base and has traveled along this line. Similarly, this ray, it should have gone along this line, but now it has deviated and has traveled along this line to reach the point H on the screen. Okay. Now what happens that as these rays have deviated, so when a screen is placed over here, suppose you place your eye over here, then what will happen as they have as these two rays and other rays, there will be other rays, okay, which will deviate and reach various points on the screen over here. So as all these rays which have passed through the biprism have deviated from their straight line, so they will appear to come from different sources, not from this source S, but they will appear to come from different sources, because now their path is not a simple straight line, but there is some deviation and change of course. Okay, so the rays which are deviated or which are refracted from the upper half of this prism, that is all the rays in the upper half. Okay, so you see this line, the straight line is dividing this whole deviated rays into two half. Okay, one the rays which are refracted from the upper half of the prism, okay, they will reach this portion on the screen, and below this line O there will be rays which are refracted from the lower half of the prism, which will reach different points on the below this point O. Okay, this region, they will reach different points in this region. Okay, so the rays which are refracted from the upper half of this prism and has reached various points on various points over here, okay, above this point O, they will appear to come from a virtual source S1, which is over here. Okay, so this they will appear to come from a virtual source over here S2. Okay, so the rays which have refracted from the upper half of this prism and have reached the points over here which is above O, they appear to come from a source S2, which is over here. Okay, now similarly the rays which have reached this point, okay, and have refracted from the lower half of the prism, they will appear to come from another virtual image S1, which is over here. Okay, like this. So okay, so as this source S2 and S1 are virtual, that's why we are showing this line as dotted line, because no actual rays are passing through this area, but these rays are appearing to come from these two virtual images S1 and S2. That's why you are showing their path as some dotted line instead of the solid lines where the rays are actually passing. Okay, suppose these 2 points are G and H. Okay, now you see here this region shows the superposition of the region where the rays from upper half and from the lower half superpose. Okay, so this shaded region is the region where the rays refracted from upper half and the lower half of the prism superpose. Okay, so where so now you see the rays which are appearing to come from the source S1 and the rays which are appearing to coming from source S2. So they are coming from two virtual images, this S1 and S2, which are created due to the diffusion of wavefront. Okay, so because you see now you see this the ray, so this ray which is refracted from the upper half of the prism, they are coming from the source S, Similarly, the rays which are refracted from the lower half of the prism, they are also coming from the same sources. Okay, so there is a division of wavefront. So a single wavefront is reaching this prism, a biprism ABC. Now it is divided. You can say that one portion of the wavefront is refracted from the upper half, and the other next portion of the wavefront is refracted from the lower half. So a different portion of the same wavefront is refracted in different way. One from the upper half and another from the lower half. Okay. So now as they reach the screen, you see the lower half of the wavefront appears to come from a source S1, and the upper half of the same wavefront appears to come from source S2. Okay. So the wavefront, so S1 and S2 is generated the virtual images which are generated due to the same wavefront, but they are refracted in different way. Okay, so but as they are generated from the same wavefront, they have same phases. So S1 and S2 have same phase. Okay, but they are two different they are two different sources. So S1 and S2 will act like coherent sources. So we can say that S1 and S2 are two coherent sources which are created due to division of wavefront, same wavefront through a because of a biprism ABC. Now this you see this conical region which is ES1H is this region of ray is appear to coming from S1, and this conical region GS2H appears to come from S2, and they superpose in this shaded region which is EH region on the screen. Okay, so here this is the region of superposition where we can observe the interference fringes. Okay, here we can observe the interference fringes. Okay, so in this way, using the Fresnel's biprism, we can observe interference fringes can be formed, and these interference fringes are produced due to division of wavefront.